Hello everybody and welcome to Handmade Hero, show where we code a complete game live on stream. I am going to take a look at the lighting we did yesterday. I think we actually have our diffuse lighting sort of working correctly now. We may have some bugs in our 4-wide implementation of it, so we may need to take a closer look at that. And there's a number of ways that we can do that. Obviously, we can just do some testing in place to make sure that the 4-wide version works the same as the scalar version would work. But really where we're at now is just time to start cleaning this code up and debugging any kind of lighting bugs that might exist therein. And so I think we're more or less done with the heavy lifting of trying to figure out what's going on. Now, it doesn't mean we're out of the woods yet, because we have to get this thing running at a reasonable rate, certainly. And we've got a lot of work ahead of us in order to make sure all of that kind of works well. And a lot of debugging, because lighting is notoriously finicky, so we're probably going to have to rig up some test cases where we can actually determine whether this stuff is working properly, right? Like, we probably have to make a fake little Cornell box we can hop into and just watch to make sure color bleeding is happening, and, you know, put some lights in strategic places and make sure that they're shining on things properly. So we're going to have to, like, go through sort of the motions here. But at least we've got an architecture in place. We can turn the crank on that architecture, and while we don't really know whether this was a good solution or not, I think we stuck with it, right? We tried a bunch of stuff, and that is really what I wanted to show on Handmade Hero, because that's what lighting is. There's basically members of AAA graphics teams who just do this all day, right? All they do is work on lighting algorithms and how to make them run reasonably, how to improve the quality, how to give artists more control over them, all that sort of stuff. It's an entire field, right? Like, you can literally go get a job where most of what you will do is work on the lighting for like 10 years, right? And that's, again, because it's such a complicated problem. While its underlying definition to write a ray tracer that actually ray traces the world, quite beautifully, but very, very slowly, while that may not be particularly hard to do, and, in a couple months, most people can probably write one that's actually quite good in terms of quality by just making sure you implement all light transfer stuff very carefully, test it well and stuff. And that takes a little while. But then it would just be right, and you'd have a gorgeous looking renderer. Problem is, it would take like 3 hours to render a scene or something, right? And so it's all of that figuring out how you get from 3 hours to 60 frames a second or 30 frames a second, at the very least. That's the trick, right? And so, it's a hard job. It's getting easier as graphics cards get more powerful. And NVIDIA et al. Start to take on more of the work for us, where they're baking into hardware some of these things that we used to have to do. Obviously, it's a nicer world. And believe me, no one is looking forward to hardware-accelerated, ubiquitous ray tracing more than me. If they can actually make that work, that would be great, because ray tracing is kind of the fundamental operation that you need to be fast if you want to do bounce lighting, for obvious reasons. And so, maybe, hopefully, these sorts of things will get better. And instead of taking, 100 hours on Handmade Hero to do lighting, it'll get down to 20 hours or 15 hours or something, right? It'll start to get like less and less and less. And that would be great. You still have to know all these concepts, so please learn them. But, hopefully, like the experimentation and the iteration, all that stuff, much like rasterization is now a more or less solved problem in terms of, like, if you want to implement it in your game, well, you really just have to learn how to call a graphics card because it's built into the hardware. Much like how that is the case, and you really just have to learn how it works, and then you can go forward. You don't have to spend a ton of time experimenting and, what's the fastest way to rasterize this triangle? Hopefully someday lighting will be more like that, but at the moment, it's not. And it's not going to be anytime soon. Like, it probably won't be in the next year or two, right? It's going to be, at best, something that's like 10 years from now. Maybe we can start taking it for granted, if we're lucky. So, oh well, you can't have everything done for you. But, at least, it's, like I said, it's getting easier, not harder, and that's nice. For a while, it was just getting harder because as graphics cards got better but didn't really have any way to calculate any lighting things for you, it was actually harder because doing reasonable lighting became this thing that you kind of had to just learn all these crazy hacks and work all these, magic things to get some reasonable lighting in there, right? And so, it definitely was the kind of thing that was more difficult. All right, so if we take a look at where we're at right now, I would say, like I said, I'm not sure we got all the bugs out of this particular thing, but it's not bad, right? We've got a sort of specular bounce happening here, but it's specular bounce on diffuse surfaces in a sense. So I'm not sure how to say that exactly. We're using the reflection vector to look up the incoming light source, but we're using this correctly summed light for that, and I think it's reasonable, right? We have to think a little bit harder about how we want to actually sample these in the pixel shader, and we also have to do a bunch more work on what do we want to represent these are in terms of units, because we have to do quantization and all that sort of stuff. So we have a bunch of details to work out, but we're more or less in a reasonable position here, right? Now, one of the things that we probably should do relatively soon is if you look here. We can't really view our profiler, right? Do you see how I can open this up? We can't really view our profiler, and the reason for that is at the moment anyway, we don't actually have a way of turning off there's no way to tell it, hey, we don't want lighting anymore, right? Like we don't need that, stop having the lighting go. So when we get something like this, it's just like black because it's computing lighting on something that can't really have any lighting computed for it. And so obviously it's just garbage. Now, as we move forward, we're going to want this. And so one of the things we might want to do today, just as a start, maybe the thing we should do is just go put, so that there can be a secondary pass in here, put in something that allows us to just, turn off lighting for our overlay pass, right? Something we probably should have done a long time ago, but just has never been a real issue. It's finally enough of an issue that's probably something we should do, and we can move on from there. All right. So I want to do that. The other thing I'd like to do is we probably should get this thing set up to do its multi-threading more properly. So I think I might want to do that first just for fun, and just because I don't like kind of the way it's sitting at the moment. So let me show you what I mean by that. So if you notice the way we had multi-threading working before, we have this sort of like lighting computation code. And the way that it works is when we actually do the lighting computation, so it should be an end lighting, yeah. So in end lighting, what we do is we just say, like, look, we're going to build the spatial partition. That happens. And I believe that build spatial partition isn't threaded. I don't actually, yeah. So build spatial partition just does its thing, right? And that's not threaded at the moment. And we compute a lighting lookup as well. We may never need that. Well, it depends on whether we end up doing light source biasing. So we may be able to remove that, but that's a separate issue. We then go ahead and call compute light propagation here, and that's a multi-threaded algorithm. And what we've got that nerfed out right now, and we've got test light sphere in there, okay? Now, compute light propagation is the thing that actually has the threading in it. You can see this is the thread dispatch. We've got one branch here that's turned off that does a work distribution, and then we've got one branch here that we're actually using that just does it on one. And what I want to do now is move all the code to work in this line, right? So I want everything to work in here. And when I say everything, what I mean is this part too. So do you see how we've got like Z slices, Y slices, X slices? These slices are independent. So for example, we've got 32 Z slices to compute. I could just send one out to each thread, right? That would be really easy for me to do. And so I want something that works more like that. And in order to do that, we have one major issue that we would need to address, but only one. And that major issue is when you look at how compute light propagation works, what you can see here is we have light probes, and those light probes are sort of strewn throughout the world. And the idea was that previously we didn't really know how we were going to sample the world, but we didn't know much about the lighting. We just knew we were going to have some light probes. So we actually have these light probes, and they kind of come through the world. You can actually see them, I believe, if we go in and draw. We had like some code that would draw the light probes actually in here. I think it's this code. So like these are examples of I think where the light. No, actually those are the voxels. Never mind. Those are the voxels themselves. So we don't actually currently draw the light probes there. Let me see if we've got them in Entity. So global lighting show probes actually controls this. That actually means that although we can't see it, it should be in here somewhere, right? Looks like that's actually not listed in here. Well, either way, it doesn't really matter because I can just set it here. So global lighting show probes. I'm going to set it to false. I might have to rerun for that, but I don't know. Yeah, there it is. So these are where the light probes are. And these are actually entities in the world. So if you look at them, they're just kind of strewn throughout the world. And the idea here was they were placed such that they would be like contained in voxel cells appropriately, right? So here's the thing. When I look at that, I'm just thinking, well, I don't know that we need these, right? Because all we really need out of this system is to make sure that for a given cell that we always take casts at least somewhere that isn't underground, right? Or contained inside them. So I don't really know that we need to do anything in particular with these probes. I feel like we could just actually use the geometry we're given to figure out where we should place our probes and cast. And the reason I think this is important is because these things come in an arbitrary order. So even if we did nothing else, we would at least have to sort them into, say, Z slices to figure out where the heck to cast, right? So I'm thinking that we should probably just try to get away without them, right? Because I'm not sure I'm not sure we're going to actually need these anymore since we're doing a fair lighting interpolation across all the voxels. It seems like we could just maybe just do it, right? And when we're taking our lighting samples, we could just say, all right, yeah, like take the lighting samples, and if the thing happens to be inside a box, just ignore that. Ignore that box, right? And I think that just kind of works. So I'm going to go ahead and pull the probes. Like, they're just going to go away. And we're going to loop over voxel centers instead. That's what I think we're going to do. So I'm going to go into the lighting here, and where we're doing probes, I'm just going to pull that because I think we just don't need them anymore. So much like we've got this, I'm just going to say, all right, that's gone. And then I'm going to clean up the code that used that. So you can see here that actually, if you look at where that's happening, it's very limited, right? There's very little that actually does anything with that. I can eliminate this pretty trivially because all that is storage. Here's the thing we actually want to modify. This part here, the work system, is just going to have to pass something else. So one pass last light probe index. What I'll probably do there for now, again, just for now, instead of one pass last light probe index, I think what I'll do is send which slice of the voxel I want to work on, right? And this is tricky, okay? So currently, and this is unfortunate, but currently I think we made a mistake. And the mistake was we made Z be the primal slice through our voxel. So if you look at the way our stuff is structured, Z comes first. So each row of light maps in our light map image is one sheet of Z. And as we go down the light map, we go down sheets of Z, or up sheets of Z, maybe you might say. As we go up the light map, we go up sheets in Z is probably the right way to say it, because Y is up in both cases. So, given that, it means that if we wanted to do the most natural thread distribution of the 32 Z slices, we would have each of our threads work on a Z slice. The problem is there may be nothing on that Z slice to light, because a lot of places in our world just won't have multiple Z slices. That will force all the work onto one thread, and that's no good. So what we'd rather do is have Z slices packed next to each other and Y be the thing, because we know there's always stuff in Y, or X, doesn't matter which one. We'd rather have that be the thread distribution, right? So in terms of locality, what we'd really rather have is one row represent all the X's and Z's of a particular Y slice, or all the Y's and Z's of a particular X slice. That would be much better than what we've got currently, which is the other way around. So I guess what I would say is I'm going to remove this, but then I'm going to first do some testing. I'm going to assume that the first thing we want to do is reverse the packing, so that the packing of our texture goes in the order we actually want to do thread distribution. So when we do lighting work here, I'm going to say that we're actually going to have here a voxel slice that we want it to work on. The voxel slice is going to be something like, I don't know. Do I want to do X or Y? I mean, X or Y being the sheet major. Anybody got any ideas? X or Y, which one's better? If the voxel remains a cube, it won't matter. If it gets changed because we're wider than we are high in terms of X and Y, because of the aspect ratio of the screen, that would mean it would break the work up more granularly to go by X, because X, there would be more X's than there are Y's. So I'm going to say X. X will be the major divider in our texture. So X will be a row. Let's just say that's true. So this is the core piece of information I'm actually going to pass. When we do light probe count here, that's not what we actually want to do. What I actually want to do here is say now which voxel thing we're doing. And so I think I want to change this entirely, because this was kind of dumb. There was no reason to do this this way. We didn't really need to do that. What we should have done is just put all the work onto one person's queue and then call it, or something like that, right? So it's unfortunate that we happen to do it this way. I'm not sure why we did it this way. To explain a little more carefully, so I think what I'm going to do is delete this, right? Put it on here. Get rid of probes per work. And in here where we say, like, okay, we've got done equals false. This is not actually necessary either now. So all of this is, we know exactly what this is. So what we want to do is say, all right, we've got an X index for our voxel. Well, I guess we can still call it work index. That's fine. So what we want to do is say, how big is the thing that we're trying to light? And it's going to be that hot dim, right? So we're trying to do, we don't want to light the large voxel, because the large voxel is just for storage. We want to do just the hot portion, the part that we actually update every frame, which is a subset of the part that we're storing. So we want the hot dim, which I don't know where that's actually stated, because it doesn't look like it is. I mean, it's it's that. But it would have been nice if that was saved somewhere else. So we may want to replace that with a local that comes in here, but separate issue. So anyway, we come through here and we say, all right, we've got a work index. This is how many work orders we're going to do. We place these work orders in here. You can see here that we've got sort of a works thing listed in here, this. And again, this, we know what this dimension actually is, right? We know that this is one per X, right? So we don't know if we'll have to change that in the future, but that's what it is at the moment. So we know we're going to create a series of work structures. Those work structures are going to be based on this. We know that it's basically assigned directly, like so. I'm not sure what this was for. I guess this is just to make sure they're aligned, because we didn't want false sharing of those structures. So, all right, I'll leave that in. We clear it. We set up the information in here. Instead of first probe index, last probe, like all that nonsense, all we need is this. So that means this goes away, and we don't really need anything else, right? Because we're going to distribute one voxel slice per. So really, the big pad is going to have to pad a little more, right? Because we're not actually going to use that information anywhere. So it's going to look more like this. And then the big pad will have to be 36 because we actually have 5 in here now. So we don't need this. All we need is the voxel X, and we can get that directly from the work index. We don't need any of this. We don't need done. We don't need this. And yeah, it's like just much simpler, right? So that's all we need. And like I said, I don't know why we did this the way we did it. We really didn't need to do that to have the if 0. I guess I just wasn't thinking. If you look in here, we're going to go through each of these work indexes and prepare it. Instead of adding it to a queue, the way to do this properly, and I didn't do it, I don't know why, is just to use the exact same code, and instead of having the if, you just put a call to do the work, right? So right here, we just say do that work. You know what I'm saying? Now, I don't know what compute light propagation actually takes because it's one of these callbacks, platform work queue callback. It looks like it just takes a work queue and the data. So basically this queue and the data, that's all we need. And then we can just say whether or not we want it to be multi-threaded by changing that switch. Now, complete all work lighting queue should just do nothing if we've never put anything on it. So I'm pretty sure we can just keep calling that in either case. It doesn't actually matter. But that's a much cleaner way to do the distribution. You can see how much nicer that is. So that's the way we should have done it. It's just not what we did. But we're doing it now, so that's okay. So once we have that, then we just need to modify this routine to no longer work on light probes. And so the way that this is going to work is it's just going to loop over the actual stuff we've got, right? And here's the real bonus. I believe, I could be very much wrong about this, but I believe this will make things a lot more cache friendly for us. Because if we do our casting updates for all of the rays that are going to be cast from a particular voxel cell, and immediately after we update the actual all of the dependent information, everything stays in the cache, right? Instead of like scattering all of our scattering our writes to this texture all over the place, then having to loop through it and grab the information in it again to do our updating, it makes this a lot more cache friendly. Now, whether we can take advantage of that cache friendliness, I don't know, because in order to take advantage of cache friendliness, you have to be able to write your math in such a way that it's fast enough that it can't, that it's faster than the prefetcher, right? But, you know, it at least puts us in position to do good work, where if we can figure out ways to make the math fast enough, the memory accesses aren't going to kill us, because otherwise they would, I think. So that's kind of a nice thing. All right, so how are we going to do that? Well, we're going to do that by saying, all right, let's go into our lighting code here, and need this. Where's my routine? Just got to grab the lighting computation end. Yeah. So here we've got the hot dim, right? And we need to grab that again, like so. And then we need to do this loop. Not there, right here. So what I want to do is I want to move this loop here. I want to, with all of this stuff where it does the all of that stuff. I want this to move into this work unit. So basically I want this to happen, all of this, to happen in here. So let's do that. We'll start by putting it down here. And what I'm going to do at the initial moment is I'm just going to do it in a separate pass here, right? So basically we're going to do exactly this. We're just going to do it in a different location so that way it can be threaded eventually, right? So again, exactly the same thing. We're just going to do it in a different place. Now, I'm also not sure why we were doing these in two separate passes here. That doesn't really make much sense. So we can weld those together as well, which again improves the caching dramatically. So, we've got a ton of fat to trim off here. This is why I was saying, like, I don't really care how fast it's running right now. That doesn't really tell us anything. We're going to have to see how fast it runs once we get rid of all the obvious cruft, and then we can start actually profiling it and see what our chances are of making it run at a reasonable speed, because it's so garbagey right now because it's been through so many iterations. As we now start to clean up this code and like polish it up a bit, it's going to get naturally a little bit faster just from not doing anything stupid. So, and then at that point we can go, all right, now start to profile this and see what we're actually going to have to turn the crank on. All right, so when we come through here, we've got the light probes, and again, like this is not useful here. We've got the probe, the casting that we actually need to do. And what I'm going to say is like, all right, so here's us going through our voxel, right? And here's us doing the transfer on this thing. And we, as we're doing that transfer, yeah, again, like I said, I'm not sure why this isn't welded in here. So I'm just going to go ahead and weld it in right now. There's no reason not to. So there's our edge coloring. So you can see, like right here, this is only operating inside one of these textures. So I can just grab this code directly. And in here, after this TX4 update is done, I can just drop that right here. Right? So that's the thing that there's no reason to iterate over the voxel twice. I don't even think I remembered we were doing that. I thought we were just doing it in one pass. There's no reason not to, but we weren't. So this is what needs to happen here. Here's the diffuse, right? We update the diffuse here. And then here's the, right immediately after the diffuse, we've got the lighting voxel updates happening for the edges, right? So I think that should just work. And that'll operate here on this thread. So then we just need the casting to be welded in line with that as well. So much like we've got the light probe iteration here, where we're doing all this stuff, what I really want is to just say, oh, okay, inside here where we got like Z, Y, X, and so on, when we actually grab out this cell, before we do any of the other work on it, inside that same loop, I want to do my casting. So my casting here, instead of looping over a light probe index, which is not actually something we need to do anymore, we're actually just going to like loop over a ray count, right? So in fact, the ray bundle, this part right here, is really all we need, right? So I guess actually it's just, that can go away. So we're going to need some way to get the voxel location out here, but other than that, we're good. And so this code can just operate directly in line. It can update all of the information that we have. We then run through here, produce the edge output, and everything's nice in line and clean, right? So you can see how this is going to be a nice, well-oiled machine. At some point, the question is it going to be a fast enough machine? We don't know. But at least all this data can be made to flow through very cleanly. We don't have to do much. And it's perfectly sliced here because it's nobody it's never touching data that anyone else is touching, right? And if we go by rows, we also don't even have any false sharing. No other thread is ever going to have to look at even this row because the whole row is ours. And so we'd never have any false sharing either because the whole giant row, we're only looking inside our own row. If we were doing it where, hey, this 10 by 10 is yours and the one right next to it is mine, well, 10 is not a cache line size at all, so we would be stepping each thread would be stepping all over each other, right? Because it'd be 40 bytes per, and they would be fighting for cache lines because they'd be talking, they'd be looking at stuff that's 40 bytes away from another person, another thread, and that would just be, there'd be false sharing all over the place. So the CPU would keep thinking it had to send information from one thread to another to avoid having the cache lines get written wrong, but actually we don't care about that at all because these two things are never using the same part of a cache line, and so we're just basically forcing the CPU to do a ton of work that it doesn't need to do. All right, so that's roughly what I want. And now we just need this thing to, I don't know what this is here for. We don't actually need this anymore, right? So that's not even relevant anymore. But do I need any of that in here? I don't think so. Light RC, no, that's garbage. So that's roughly what we're looking at. And when we come through here, we're going to probably need some of this stuff, like, the information about the voxel that goes on in here. So I'm not sure how much of this we need, but I'm pretty sure none of this gets used in here anymore. So I'm pretty sure all of this can move out to the other side of things. So I think all of this can go in here, right? Probably. And then when we have the random series in here, you can see how this thing was working. And to be completely honest with you, I'm not sure that this is a very good way to do this. In fact, I can pretty much tell you it's not. There's no real reason for these people to be writing to the series cache line. That doesn't even really make any sense. So if you take a look at what's going on here, we need an entropy source in this case, right? We need an entropy source so that each of these things, when it's doing its randomization, it needs to be able to do random choices, I think. I'm not sure if it actually still does, although if it actually doesn't do that, I guess we don't care. All right, so never mind. We don't have to care about that. I was going to say we need the random series, but we actually don't at this point. So forget I said that. So now all we really need is just the location to do our sampling from, and we should probably be good to go. All right, so let's get rid of some stuff. We don't need this. We do need the commands, so these two things we probably need for this. Although the light voxel dim thing, again, I think I'm just going to nerf that for now. I'm going to say this is actually going to be the light voxel dim. And I think we're going to need to run through this code and clean up where people are getting their constants from. Just because there's so much of it now, and now that we know what it is, we should be able to do a nicer job on that. So that's kind of a little to-do that should be in the back of our heads. So here's us looking at the light probe. Again, we don't actually want that, so I think what I'm going to do instead is just say, all right, for the light probe, we're going to actually ask for... we're just going to ask for whatever the center of the voxel is right now, which may not be a great place to ask, so I'm going to put a little to-do here, like... So that light probe P needs to come from somewhere where we actually know where the voxel is, right? And test light square is one easy way to do that. So I think in vox center P here. So we should be able to do something like that. Now, that's not the actual center, right? I mean, we need this to actually produce the UVW of the voxel, and so on. So we don't really want that. We probably want the test cast from probes. So you can see in test cast from probes, right? We say in here, this cast, oh, well, no, that's actually also using the probes. We need something that tells us where the voxel is, right? I mean, that's what we actually need. And so it would really be this, right? This part right here. So we probably want to do something like this, where we say, all right, the box center P is whatever the min corner is, and then we add to the min corner like the voxel D times the XY of it, right? And then the light probe is just going to be, for now, it's going to be that directly. Something like that, right? Yeah. We don't do this light probe index probing anymore, right? But we probably want to keep this code for somehow, right? And so we probably want to have a way of pushing debug lines for something. What we'll do is we'll leave the code if zeroed out, and in here we'll maybe say like, oh, if, you know, this will eventually be like some kind of if we'll do that has to, we'll do an if here that is based on which voxel it is or something, right? So we'd do something like, oh, if like x equals blah, and like y equals blah, and z equals blah, then do it, right? So we will do something like this, but it just won't be exactly this, you know? All right. So moving forwards, the dir sample index, like, it's not going to be a light probe index anymore because we don't really have that. And so we're going to need some kind of so we are using the series up here. So I think this just needs to be sent down with it. So what I'm going to do is say, look, those are the only two places we get it. I'm going to put those in the work order. Like so. So what we're going to say is there's going to be an entropy seed, right? And the entropy seed needs to somehow be like a munged version of something that these people can get their entropy from. I guess if we only need two, maybe I'll just put them both in there. Is light point entropy even used? What's it used for? Okay. Well, all right. We'll just put them both in there. Would love a thing in C where you can just say, I want a pad structure here that pads out to this many. Which is not the same as alignment, by the way, because I may want to address that pad in a way. And ask how big it is and stuff like that. And you can't really do that very effectively with just an align thing. Anyway, so inside lighting work, I want these two things. I'm going to pull those out, right? So I'm going to do this in the work distribution. I'm going to get the series there. So we're going to say this, sort of, right? Get those two entropies by looking at the random series in the solution. We're going to pass those down so that in here, where we actually get this, we can just pull them out. And that way, nobody is bottlenecking on sharing that entropy source anywhere, right? So that's much nicer. Then in here, we can say, well, light probe index isn't really what we want, obviously, but we can do like a, you know, z times hot dim plus x or something like that, right? So we can look into the sample index by doing some kind of a, you know, weird, you know, fancy thing here, right? Where we, actually, let's do y. Where we, you know, do generate a point index for entropy's sake, right? All right. So whether we're doing a debug or not should probably be something that we set up here. So it should probably be like debug this, and we set that in sort of a more constant way, like so. And that way, inside the subarray thing, we can look at the same thing, At the moment, that's going to be nerfed out because, again, I don't really want to look at raycasting yet. That's sort of a getting ahead of ourselves, to say the least. So let's go ahead and just clean that up a little bit and see what else we got. All right, so we now have to write out to the voxel C. So that does mean we do need the command structure in here. We need some way of addressing the texture. I don't know that we actually want to send the whole command structure down. We may just want to send down the pointers to what to write to. So it's hard to say. Like, I'm not sure which we want about that. So that's a good question. I don't know. Yeah, I don't know exactly what we want to do about that. For now, I guess I'll send it down. But maybe I don't know that we want to do that long term. It's hard to say. I don't want to commit to that. So anyway, let's say that we're going to send it down so that the command structure does come through. So this is going to be in the work order. So it'll be like here. And we'll just grab that out. So when we set up the work, we'll have to put that in. So in compute light propagation, we need to pass that down. So when we call compute light propagation, which, by the way, we need to start calling, we'll pass that down. So compute light propagation will now kind of always be called. And test light sphere is actually something that we would call in a different way now. So test light, like this should just always work this way, where we compute light propagation multi-threaded always, if we want. I mean, we turn off threading anytime we want to test it without that, but is going through that path. And so the test light sphere call, I actually want to be inside the thread part. So basically, when we do our compute light propagation, we can choose to or not to do the sphere version as test code separately, right? So the test light sphere would actually go in here, right? And be a way of obviating whatever was happening with the raycasting. So for example, it could just look like this, where we have like, you know, if 0, else test sphere. Like that. That's what we want to do there. So, all right, we have to have our game commands, our game render commands pulled out of the work order. We need to set that when we do our lighting there. We don't need this anymore. And let's see, we've got the block copy voxel, begin lighting computation. I don't actually know what this was designed to do. So I'm just going to remove that. All right. So we've got our test cast from probes. That would be another thing that would happen up in the, all of this stuff would be happening up in here now. So our test light sphere, same thing. And let's take a look at now what we've got. So in our compute light propagation call, which is now multi-threaded, I think I'm going to go ahead and weld that into the other routine so that we don't like call out to it for no reason. Like basically this is the main workhorse now. I'm just going to put that directly into that other call. So right here. There's no need to call out to a function for that. So instead of calling compute light propagation, I'm just going to delete that and have this work distribution happen in line. It's very small, and it's most of what we're doing here anyway. So I feel like that should just be directly in line. That's because that's really, I mean, that's everything we're doing. It's what the whole point of this routine even is. So calling out something to do the only thing you do doesn't really make much sense. So I'm going to go ahead and compile that. In testcast from probes, you can see us still doing the probe here. What I want to do is just have this be something that works with the voxel directly. So basically, testcast from probes is going to change to something else. It's going to be something like this. It's just going to be testcast, and there's going to be like a ray position kind of a thing, right? So you're going to pass the, you're going to pass the cast p in there, and this is just going to do a test cast. Like that. So if we want to do a test cast, it's pretty easy. We just call it with the casting location. So that means in here, right, where we've sort of got our platform work queue callback, and we've got various things we can have it do. We want the raycast to be one of them. We might want to move that into its own routine, but basically what we want to do is something like this. Have a way of doing the actual cast, have a way of doing the test cast, and have a way of doing the test sphere. Right? So we can sort of define what we want here, like, you know, which one of these we want, and that's the one that'll actually get done. So we can have like test cast, test sphere, you know, this sort of thing. Maybe this. Something like that. And we can just switch which ones of these we do and go from there. So then at the end, this one's the actual raycast. And like I said, I might, because it's just, it'll get welded in probably by the compiler anyway. And even if it doesn't, there's so much work that it does. I don't think it will matter if it was a call or not, because it's got just a huge crap ton of stuff it's got to do. Sadly. Yeah, I wish it was smaller. So I'm going to go ahead and pull that out and just put that in here. And, you know, we'll see. If it becomes a problem, we can weld it in later. And so we just have, like, we either do a test cast, a test sphere, or our actual raycast. And those are the three things that we want. So then we just need to call them with the right parameters, but otherwise we're good. Let's take a look at what they actually need. So testcast just needs a solution and a cast p. I don't know that it needs anything else because it's not actually doing anything else, right? So to do the testcast, we would just do solution and that cast p location. So it is right here. And this is kind of nice too because it means this will kind of feed forward properly. So there's us producing the centering information. So we're going to say test cast from the box center. We'll say a full cast from the box center. And the test sphere will do the same thing. All right. Let's see. What do we want to do here? Wow, too much code to move around and too much to simplify. So, when we do these test casts, we want these to just give us back, we really just want these to just do their right. You know what I mean? So we want these to do the writing for us. This voxel offset C and D stuff needs to be simplified and made cleaner, obviously. So we want to take care of that at some point. And we'll get there. But let's go ahead and finish up the rest of this. So if I have full cast here, this does the full raycast set. That's going to need everything that this thing needs. So that needs the lighting solution. It's going to need the light probe P. Actually, suppose we'll just leave it that way. And it's going to need any of the sort of dependency stuff. So it's going to need like the sample point entropy, like all that stuff. So I think we probably want to pass the work down. So we can grab that stuff out. Like so. And other folks might need that too. We'll see. We don't know what they're going to require for writing and that sort of stuff, but we'll get there. All right. So this gets passed. Don't know why I did that. Solution gets passed. We don't need that. I suppose technically we don't need the solution then because it can just get it out of the work structure. So here you can see we need the sort of point index for the entropy. And I suppose we need the voxel location in general for other things potentially. I guess I'm not 100% sure that we really need them because we could just pass down the location that you're writing to as a pointer, which might be smarter. And then you're just going to do like offsets of that. Have to think about that. Yeah, so thinking about that, I think we just need the voxel cell itself for that, for these parts anyway. Because when you do, like, spam voxel is not really what we want, right? So if you look at spam voxel, it's doing a bunch of crap that we don't actually want it to do. And so when it's doing this update step, we really just want that update step to be baked into here, right? We want that update step to be baked into here. So from now on, this is really not doing any of this. It's really just going to do a like update voxel step. It's going to take the light voxel cell that you're talking about, like this, and then it's going to blend in the light C and the light D that you were talking about, right? So it's really this, I think, is all we're actually looking at now. So update voxel is going to take the cell in question. It doesn't need anything other than just the information for writing into that cell. And I think we're good, right? I might change the order here. So I might just say, look, give me the information about writing first, and then we'll do the other part second. All right. I think we're good. So I think that's what I want, and that means the lighting cell itself should probably pass, the light voxel cell should come down here, right? So it should be like light voxel cell. And then in here where we do this, we need that entropy index, so I might make that a thing that we pass down to. Something like that. And that'll just be something that we keep track of for our entropy seed in here. And I don't know how exactly we want to do that, but it's like something we want this thing to keep track of, right? Not you, but you. All right, so something more like this. So we have the entropy index, the center P, the cell, blah, 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 right? I think all that seems reasonable. Get the test cast, test sphere, full cast. All right, we got some work to do here, but we're all right. Still going relatively okay. So when we then go look at some of these other guys, well, let me just see if that got rid of our errors for this. What is this, the T update blend? Yeah, so the T update blend, I think we're just going to want to hard code in here for now. in update voxel. So I think that wants to probably be in passed in like this. So when we do our excuse me, when we do our voxel updates in the full cast, I'm going to just pass that t-update blend in there. I don't think this thing needs to be looking up in the light solution. All right, so yeah, then we want to call update voxel the same way in our test castor. The oct offset and all that stuff just needs to get rearranged here, but otherwise it's the same. We've got the light C, the hit D, we got all that stuff, right? So we have all that, and we just need to pass the t-update blend, which again would come from exactly the same place. For some reason, this is out of order. Don't know why that's the case. There we go. Let me fix this now. What's the problem? I see the problem. Okay, so now in here, we also need to pass the light voxel cell again. And that's, again, just because we got to blend into that particular cell. So we're going to do that here. Our entropy index plus sample point entropy. So that really is just for each individual sample point. So that's actually should be masked. Where did that sample point entropy come in? It's supposed to come in right at the, yeah. It's supposed to come in right here. So that should actually, I should have cut and pasted that whole thing out here. That's the complete equation for the entropy index at the moment. All right, so now we need to know where is the moon. Obviously something everyone always asks themselves. Let's grab that, put it in here, because the moon only exists inside the full ray castor. What else we got? All right. So now, since we're going to run our test sphere through this particular path, I need to make sure the test sphere actually works. And so that's going to require me passing, looks like the solution in the group down, right? And when I look at that, I'm like, nah, I don't love that. I don't think we really want to do that. So I think what we'd rather do is, like, you know, take the late lookup voxel dim, get rid of the group, do it this way, and then when we get rid of all this stuff, figure out what sort of things we're actually looking up here, like voxin, total dim, and stuff. Like, let's figure out why we need to get that from the setup. Let's stop getting it from the setup. And then when we actually call that test light sphere, I want to probably do it in a slightly different way. So when we call the test sphere, I don't want to loop over the voxel this way. I want to loop over the voxel in the outer code, right? And just call in here. We probably want the debug code to get placed into the routine for drawing. So we probably also want that here, right? And we have the box center P already, so we could just leave that code in here. So this is just if we want to see those debug voxels. So I'm going to leave that there, and then work on this code, the test sphere code up here. So we only need to do looping over the interior texture, and then I think we're good. So taking a look at the equations here, we probably don't need a lot of this stuff. So like the light UVW is really just mapping the light in there. I'm pretty sure the inf total dim is actually in the solution itself, right? So we have that code, don't we? I guess we only have the cell dim. But the inverse voxel cell dim, right, like we can compute both of these things. The voxel min corner is definitely in here. So looking at the way this is working, yeah, I think we can just change this around a little bit. Let's not do this in light and UV space because it doesn't make any sense. Let's just have this pass us in the box center P. We'll delete this. We'll come in here and say, okay, let me know, you know, when we're doing our light normal, we just need to know which direction it's facing. The distance is going to be a little bit weird here because it's going to be in world space instead of UV space now. So we're going to have to adjust the brightness of it. But other than that, we should be okay. So what we're going to do is say, all right, come through here, light P minus box center P. That's all we actually need. We don't care about the Vox UVW at all. We already have the voxel cell that we're writing into because the outer code has computed it. So we can get rid of all of this. And plus, this right here is actually a voxel update. So we could actually just call update voxel, but we're not going to right now because we're using the test sphere. So that's fine. But eventually we probably will. Okay, so now let's clean this code up from here. Let's see what we've got. So here's our ty loop, here's our tx loop, and it looks like we pasted this in a little too early. So this was actually supposed to have a close on it, like there. And then these two loops were separate. And off we go. Okay, so ton of major changes there, so we probably have to do like at least one more pass on this now to clean this up and get rid of like stupid mistakes that we just made. But now you can kind of see we're getting closer to reasonable. Okay, so let's see what we have here. Code is getting smaller, and that's very good, right? Looking much nicer. We don't really have to test if we're inside things anymore, because we only step through things to begin with. That seems good. In fact, none of this stuff is necessary anymore. All right. I'm not sure. So I don't know what this get a radiance bit is here. Look up voxel clamp. So, I mean, you can see like we can just remove all this code because now we're just going to step through the voxels directly and we never have to ask whether we're inside them. And that's pretty valuable, right? Because we can just avoid a ton of work by just knowing that we never have to actually do that, right? So I think we should be okay. Oh, I lied. So when we actually do the sampling, so that's not true. We will have to, where's that clamped? We still don't need this one. But we do need lookup voxel clamped. So we still need get lookup voxel clamped, and we need that for the reason that we do the blending in the voxel for when we have to do our radiance lookup when we cast rays to see what we hit, right? So we do have a little bit there. But otherwise we could still get rid of the rest of it. And so are we not using the get a radiance anymore? Yeah, so this was just us doing that sampling. So it looks like what we're doing currently is just sampling the light color without actually doing any kind of bounce computation. So we probably do sort of want this at some point, but it'll probably just get welded into here. So I'm just going to go ahead and say this is an if 0 in here. And we'll move it back. So sine square root is also not used anymore, so we'll get rid of that. I like looks fishy. Looks fishy is awesome. All right. So I think we're good now. So now we just have to go through and start debugging this, which is going to take a while, right? But it looks all right. And if I remove a bunch of this dead code here, we can sort of see it start to take shape. I'm going to move init lighting down so that we basically have our flow here. So we call init, then begin, then end. So the last three functions are the functions people call in from the outside, and everything else is something different, right? Our irradiance pack, binormal to normal, these are not really used at the moment, and I think they're probably going to have to get written differently. But we'll leave them in for now because we don't know if we might want to use something similar. So we might just keep them. We got the rest of our stuff here, spatial partition. All that stuff looks good. Our work queue callback. All of our different types of updating now. We've got our test cast, our test sphere. And then we got our lookup code. Looks pretty good. I'm totally fine with that. I'm happy with that. All right, so now we gotta actually fix this stuff and get it working properly. I don't know why this is declared external. Is there any reason to do that? No. Also, I don't know why any of this stuff is declared up here either. Is any of this stuff necessary to be declared up here? I don't think so. Just see. So I think we're good. All right. I am now ready to say this is a light pipeline that we can start to get behind. And now we just need to kind of like focus on it and start to turn the crank, right? We got to like get serious here. So first thing, let's just fix crash bugs, right? So anywhere where we get an assertion or a crash, let's just clean that up first just to make sure we're working on something that's actually running. You can see here that it looks like our work size is not correct. Oh, you know what? So I removed the thing where we actually allocate those. I probably shouldn't have done that. We probably should still do that because we want the alignment. I failed to think about that. So in the init lighting, let's continue to allocate those work units, even though there's no real reason for it. Let's just do that anyway. So we'll just say, look, push array, arena, light lookup of whatever these things are, lighting work. And we'll align. I don't know what that true is. What's that? Oh, whether we want it cleared. We don't need it cleared. So then we got some other stuff here. We've got an accumulate PPS. We don't need that anymore. So let's just get rid of this crap. We got memory getting allocated here for stuff that we don't even do. So that doesn't have to happen, right? To say the least. And I guess I need to specify false there. Okay. Back to checking for crashes and other assorted funnesses. So we're having a really slow run here, but I'm not sure why. So something's confused. Let's see what's going on there. So we're running the test sphere code, yeah. Oh, I know why. Sorry. We also now need to stop looping over everything, right? So we need to only loop over one of our rows. So you can see here in the work queue callback, we do the entire voxel, and then we do it 32 more times because we're calling this 32 times from the work queue, right? So this needs to get fixed. What I'm going to do here is instead of actually slicing along X, because that's a pretty big change, I want to do that change as a separate change. So what I'm going to do is just fix the Z to the voxel X since they're symmetric, and we'll just only do that Z slice. Again, that's not what I want to do at the end of it all. I actually want to do it along X's, but again, that's sort of a separate thing. Okay. So again, not seeing anything, so we've got some, we got something crappy going on here, which is fine because we're going to debug this, like I said. But actually, it's running okay, so we don't have any issues with that. So at the moment, we, looks reasonable. No crashes. We have to figure out why we're not getting a light update there. So we should be going through everything in order and doing our test sphere. So now we just have to figure out why with the test sphere isn't writing anything out there. You can sort of see us pulling out the cell lights here and writing them back. So I'm pretty sure that's happening correctly, or at least should be. So I'm just going to go to test sphere and see what's up with that. Because again, we modify this, and also like the intensity stuff is wrong now, and so on. So let's figure that out. In here, we've got sort of our light position. I don't know, is the inv hot dim even used in here? No, it's not. Yeah. So if we start to look at what's going on here, I'm gonna also, you know what? Let's just do this where we're gonna set whatever the direction is. We'll use that as the light just to see if that shows up. It's a good idea, actually. There we go. So here you can see us running the code, right? And we're running, the code's still running single-threaded, and we're using the test sphere's like directional clamp, so it's just setting in whichever direction we're going, that's what we get. Now, remember, we're doing a diffuse sum over this thing, so what we probably want to do here is make sure that we set these to lower values in general, because the diffuse sum is going to put a lot more power into the system. So what I might do is say, look, let's actually set this to be sort of a much less bright debug pattern, because as the diffuse gets blown out, we're going to get those different colors, right? So this is more like what we would expect, right? And you can see now in the direction to the light is getting placed in there. Now, one thing you'll notice that's not good is we are running the test sphere. Those things don't ever look like they're changing. They should be changing, and they're not. And so this... oh, well, no, actually, never mind. That's not true, because it looks like that's just based on where they are in the texture, so that's fine. All right, so now I want to see if I can call this multi-threaded properly, because I think we should be able to, because, I just want to make sure we didn't screw anything up there in terms of the distribution and who's running to what. So I should now be able to, in the lighting computation code, switch to adding these into a work queue, and it shouldn't crash, right? If it does, we've got problems. All right. So here's that running the code multi-threaded, and again, it's all working nicely. The only difference is now it's like much faster, right? So the code's running much better, but otherwise it looks effectively the same. We now don't need those light probes, by the way. So I'm going to turn the rendering of those off, and eventually we'll remove them. And that'll also save us a ton of work in other places. Oops, that was wrong. where's the draw the light probe thing? Oh, it's the show probes. All right. Okay, so now we just need to, since we know we can write into this thing properly and that our code is not like totally busted, we need to do something where we can fix the system to write the test sphere in and verify that we actually get our test sphere properly, right? Because this all looks like it's working. Why do we have a hole? That seems bad. I'm not sure why we're not filling in part of that texture. We're going to have to debug that. That looks like a bug, right? I'm not sure what's going on there. Our frame time isn't horrible right now. It's not good, but it's not horrible. But you can see everything is in the compute light propagation work function, so that's good, right? That's the part we're working on. So that's a good thing. If we take a look at our thread distribution, you can see that we've got like 6 of those fellows kind of doing their thing. Here's them doing each slice of the voxel, right? Okay. So now let's think about this a little bit more. Let's go to the test sphere and try to get that running. This should work. We have a global light position, and we have a center P that's in world space, right? So this should all work. The only thing that might not work is this part. Because we changed from UVW to just using the center, to just using the world space, rather. So the light distance the fall off here is probably way too large. We probably don't actually want that to be the case. In fact, none of this stuff looks like it should be the case anyway. This is just dumb. Whole thing looks pretty stupid, actually, if I'm honest about it. So we probably want to do is say, look, the light intensity starts here. We're going to have a fall off that looks like that. I don't know what the how bright this light should be. That doesn't matter right now. So we're going to clamp that, and then we're going to use that to output our value. And what we probably want is this light distance to have a light fall off factor. So we can basically tweak it to whatever we want. So I'm going to call this light fall off, and I'm going to put that as a multiplier on the distance. And so if we want to, we can say, like, look, the fall off factor gets higher as you want the light to fall off quicker. So we'll call it light fall off rate. And then I think we should be okay. Yeah. All right. So as I suspected, like, it looks like our light sphere code is still fine. The main problem was that when we were working with it before, we were in UV space and we changed it to not be in UV space anymore. So then we end up with sort of this, yeah, you know, exactly as you would expect. The situation is that the lighting was being computed with too tight a radius because it was in UV space, so it wasn't lighting anything. So now we're getting our lighting, it looks right for the most part. I do think we have some work we could do to clean up our edges a little bit here. You can see our edges are very voxelized, and I think that's, again, because we don't put any negatives in there. So I think that's, you know, a little bit of an issue. So I don't know, like, you know, I just want to see, sorry, you have to indulge me for a second here. If we just clip the lighting down a little, so if inside the fragment shader where we're actually computing the lighting, where we do this interpolation, I'm just wondering if we clamp it down a bit if that will, again, clean up those edges. So inside the light sampling, you can see us getting our texture sample. We sample all these, we interpolate them, and then we output the results. Basically, I just want to clamp that down a little bit. So rather than falling off at 0, we're going to fall off at like 0.1 or something. I just want to see what that does. So after this lerp, where we produce the S, what I want to do here is say that let's drop that S down. So let's say like S minus equals V4 like 1, 01, 01, 01, 0 or something, right? So drop that light down and then clamp it, right? So clamp S. Oh. Know if that works. It might not. Oops. So I guess we want that light fall off rate to actually be 1. Oh. Or not. So, you know, it's a little lumpy. I'm just going to play with this a little bit. I don't know if there's any amount you can drop it down by that would remove the lumpiness, but you can see it looks like way better already, right? It looks like way less voxelized. I mean, it just looks way better, right? So, yeah, never, never, ever interpolate to 0, right? Always bad. You always want to interpolate something slightly other than 0 because you're going to get like a nicer result there. Something I never really thought of till Handmade Hero, you know? So, all right. And again, we're still doing that specular sample, so I'm kind of moving around to see how it plays out, right? So it's like right here, bounces up, hits the light source. It's looking pretty accurate, actually. I like that results. We don't want to switch that lighting up until we really get to a point where we're done, because again, without the specular bounce, it's hard to really see if the diffuse is working. So I think that's like a little too. I think we need more like 0.2 on that reduction in order to really like clean up those edges. I don't know if 3 is the best answer, but I think that, yeah, that looks really nice. Look at how clean that sphere is. All right. So I'm going to consider that a pretty good success story there, because that's actually working really nicely with the test sphere. We can now try our test cast as well, just to see if that works. We might as well have both of these working, because we're probably going to need both of them as we do our debugging. So let's go ahead and get that working. Just going to make sure I'm passing the right things here. So it needs a cell in the center, just like everybody else. And let's see what that does, if that does. Oh, we got an is test case. What is happening here? So is test case, wait, but is test case should always be false. Or is test cast, rather. Where was that happening? Get light leaf for P. Oh, it was sending down true for that. Interesting. So one thing I don't know is push debug line actually thread safe? So push debug line is not thread safe. So we really don't want anybody to pass true always. Like we want to make sure only one thread is calling that, or we go make it thread safe by just using a locked increment of some kind. But yeah, that was not supposed to happen that way. All right, so here's our test shadow code. We're going to need this light to be a little bit brighter. Other than that, I think it looks like it's sort of working. This will be way too bright, probably. But off we go. Getting like a lot of popping there on the Z. Like, I think we have some weird, like, we still have that Z that we're using for interpolation is still not stable in the way that I want it to be for the alpha. So I don't see any obvious bugs in the test caster. The test caster seems to be producing fairly reliable results. You can see that our voxel is not aligned properly. Like when we hop over here, we're having some issues with that voxel. Like the light voxel is now in a place where it cuts off right here. So we're gonna have to place the light voxel more carefully. We knew that was the case already, but now it's pretty obvious because the lighting works just fine, but then the voxel ends and you don't get any lighting, and that's not good, right? But otherwise, pretty good. Looks pretty stable. So I think all of that looks pretty reasonable to me. That's probably a good place to stop for today, honestly, because the next step would be to start working on the actual caster. Performance-wise, it's not great at the moment, right? And we don't really know why. I mean, we kind of can assume there's a number of things that are reasons that probably would be slow, especially like, all of this code where we're doing tons of loops and stuff like this. So it's not like it's a mystery as to why it would be slow. But we haven't actually profiled anything. So although we kind of more or less could guess why it was slow, we probably don't want to just assume. So that's, the next step for us, obviously, would be to start to look at what we can do to speed this stuff up. Excuse me. So, yeah. But otherwise, pretty happy with that. I'm going to go ahead and go to Q&A because I don't want to start a new thing. Next weekend would be when we would start on this stuff, I think. How come I can't type? What's going on here? How come I can't type into this window? There we go. I don't assign the clamp of S back to S. Oh, sorry about that. Shouldn't we have seen some artifacts for that? Kind of weird that we didn't. Shouldn't we have seen some artifacts due to that? I feel like we should have seen some, but I guess not. That's kind of surprising, right? Shouldn't wall side be in light state? What is light state? Well, I have no idea what that question means, by the way. if we like the voxelized light, can we keep it? You mean if you like not interpolating it? So meaning if you would rather do like, you mean to say if you just don't want that smooth edge, so you want it to show the grid like this, more directly, like that? Is that what you mean? I mean, you can do whatever you want, man. Like, you know, when you write your own, you'd use whatever algorithm looks best to you. It's your call. Can you show the disassembly of transpose in an optimized build? Sure. I mean, the transpose is just 6 shuffles, right? That's all we did. So, it's not interesting. It may require some, like, we didn't necessarily do it perfectly. Like, we didn't think about how it would have to happen in registers. So if it doesn't insert a V-shuff, it may have a problem with having to copy, but that's not an actual operation, so it's fine. But yeah, sure, I can show that. It probably never gets called. It's just inlined, right? So Remedy probably can't breakpoint on that. Where is it? Where is it? There it is. Why can I not set a breakpoint? Oh, I didn't realize I was scrolled over. Yeah, that's what I was trying to do. So you can kind of see some weird stuff happening here. And I'm not really sure why it generated the code exactly the way that it did. But it's interleaved these instructions. But if you want to look at what happens with the light C transpose, you can see here we've got the shuffs. There they are. So it does a shuff PS here and here. It clones one of the variables. Again, this instruction is free. It's just a register rename. And these each take 1 cycle. And they can't be executed in parallel, so this is free. It just, like, this doesn't count. It just gets executed simultaneous with, like, this in the front end. So it's 1 cycle, 1 cycle, 1 cycle. I don't know what the heck this is doing. I'll be completely honest with you. I have absolutely no idea why that's there. It doesn't really make any sense. Well, you know what? It probably just wants to get the writes started, is my guess. So it's probably just trying to get these stores started. It probably just thinks it's better to put them up in there, I guess. So it's taken this code and shoved it up in there. That's fine. Anyway, here's the next shuff. Free register rename, and the 2 more shuffs. And that's it. These are just these writes from down here. I don't know what that is, because that's an aligned write. And I told it not to do that. So I'm not sure what that actually is. That may be a different thing it's trying to store for some other reason. There should only be 4 of these, and you can kind of see 1, 2, 3, 4. So that, and that, I don't know what it's doing. That's not part of our shuff. That's some other thing. Like, I literally have no idea what that is. I'm going to guess, because it's on RSP, that what it's doing here is it's going to use 4. So it had to spill the stack there. But why it had to do that, I don't know. Like, why it would do that every time through this loop, that seems really dumb. Like, it should have done that out here. So all I can say is that looks stupid to me. These look stupid to me, these two right here. But they may not. I mean, I haven't analyzed this code for more than 16 seconds. So, you know, take it with a grain of salt. That looks dumb. Those look like they should be getting done somewhere else. Actually. Because all that looks like it's doing is just saving... all that's doing is just saving the contents of those registers. And that doesn't seem like something you would be wanting to do inside the loop. You'd do that outside the loop, right? So unless it's actually using... Yeah, no, I mean, and you should... It looks like you have enough registers for what you're doing. That looks like it's ill-placed to me, but maybe I'm wrong. I don't know. Can we zoom out on the octahedral debug drawing? Yeah, but it's just more of the same thing. Why does the clamped light have a kind of heart shape from some angles with the sphere lighting, 2 lobes jutting out behind the hero to his left and right when viewing from a low angle? So I'm not really prepared to say exactly what's causing that because we want to investigate the lighting a little bit further, but I believe that's just because the octahedral map is on a diamond pattern. And so when you're going to get the interpolation on diagonals like that. So it's going to naturally form heart shapes rather than, any other shape. Maybe you fixed it up already, but I think you might have a copy-paste error in the border fill. If you look at the sphere test, the octahedral map show a weird black line on each. Yeah, that I mentioned that when we were there. I'm not sure what that is. How come this isn't running? How do I make this run? Run. Why is the program suspended? What's going on? There we go. If we try to force ourselves into an area where we should see some border copies, which I don't know where exactly that would be. So I'm not sure. What I would say is maybe we should just turn on one of the tests. The test copies. Like the edge coloring, right? So, we could force it to do an edge color test. Looks like we don't have our edge coloring color. Oh, yeah, we do. I guess we don't have a way to quickly test that. I don't really want to look at that yet, right? Like, I want to look at these more carefully on when we're actually going through and doing the debugging. But I'll make a note, like... How will you light the top of the walls but make them block light in the middle? So do you mean like that area, like this part of the thing? Or I'm not sure what you mean by that. And yeah, it does seem like the wall sides are the wrong color for some reason, which I'm not sure why. That seems odd to me, but I'm not sure where that's coming from. Like I said, we've got a bunch of stuff we have to do, like test-wise. I don't really want to look at it at this point. I think it's probably, my guess is that it's not actually a bug at all. I think the reason we're seeing that mostly is probably just because of the way the test cast works. So the test sphere, which puts light in the whole hemisphere, that one works properly for those directions, right? Well, properly, in so much as you can call it the test proper. So that when you could have seen them, I think it's working like okay, right? So if you imagine like where the light actually is, you know, it's probably at least within a stone's throw of correct, although not probably correct. The test cast does not, it just knows if it hits the light or not. So it doesn't actually properly tell you any other direction of incoming light. So when you switch to the test cast, it's like, can this wall ever hit the light or not? And the answer is probably like no all the time, right? You can even see like it's not updating any of that part of the texture because it never takes any samples in that direction, right? So the problem here is it never knows, right? It's always casting towards the light. It never can find the light in that direction because there are no like actual pieces taken for that direction, right? So I think that's mostly what we're getting. But again, not sure yet. So we'll see when we look at it more carefully. For lighting the wooden top, I'm not sure what we'll do about that. But remember, the lights may be like up higher. We don't know what we're gonna do. We may like make the walls taller. Their occluders may be taller than they are, for example. In terms of what the next step is, we just need to actually track our light values all the way through, test everything, make sure that with test cases now in the fused version, everything flows properly and the copies are proper and like light quantities are proper and that sort of stuff. And then we switch to the actual ray caster, which we have, and make sure that that works properly. And then we've got just optimization ahead of us after that. Am I planning on putting in tone mapping? I don't know. Probably nothing fancy, but we might put in some halation. I don't know that we'd put in any tone mapping, though. Does it take a significant amount of time to switch headspaces between different programming projects for you? And do you have any techniques that you use to refamiliar yourselves? No, it doesn't really take me any time to switch the headspaces. But what I would say is I don't really like the fact that I have to work on Handmade Hero because it occupies background thought time that should probably be spent on other projects. So that's been annoying. So basically it means you're spending less mental energy on your other projects because they're getting less background time because Handmade Hero is taking some of it. All right, that looks like it. Thanks, everyone, for joining me for the episode of Handmade Hero. It's been a pleasure coding with you, as always. I think the lighting's in a pretty good state right now, actually. The system's looking pretty good. So I think next weekend we can start to dive in and just test all the paths, put some debug values in everywhere, make sure we get out what we expect. Basically just run through a full due diligence, lock it down, and then say, okay, now's the time to get the raycaster outputting good data. And I think we're thumbs up, right? We do have some optimization challenges, but even just looking at it now, running relatively fast using the multi-threaded version, I do think that's nice because if everything's segregated by threads like that, it means at the very least it will get faster with new chips, right? If it's a single-threaded slowness, that's a problem because that doesn't get faster. But a multi-threaded slowness does get faster with new chips, so that's a good place to be. So I think we're in good shape. So I'll be back here next weekend to start that. In the meantime, if you do want to follow along at home with the series, you can always pre-order the game on handmadehero.org. It comes with the source code, so you can play around with it yourself. Try out your own lighting solutions if you have got some ideas. So I guess that's about it for this week. I'll see you back here next week. Until then, have fun programming, everyone, and I'll see you on the internet. Take it easy.